Here in session 81, we're going to be taking a look at square roots of products. What we're going to show here is that a common method for representing square roots is not only the radical sign that we took a look at before, and this is the radical sign, but it's also to use a fractional exponent. For example here, the square root of x is the same thing as, it's equal to x to the 1/2 power. Now, in order to see how this works and why this works, let's take a look at a few examples of solving problems that have the same base that's being multiplied by another number of the same base, but they have exponents involved. For example, we have 2 to the 2nd power times 2 to the 3rd power. Well, since we have the same base in both numbers, 2, we find out what our answer is by taking our exponents of our common base and adding them together. 2 to the 2nd times 2 to the 3rd is going to be 2 to the 2 plus 3. If we take our 2 exponent and add it to our 3 exponent, that gives us 5. 2 to the 5th. Likewise, in our next example here, 2 to the 1st times 2 to the 1st. We have the same base, 2, so we're going to add our exponents together. 1 plus 1 is 2. So 2 to the 1st times 2 to the 1st is the same thing as 2 to the 2nd. What is 2 to the 1st? Well, 2 to the 1st is 2, times 2 to the 1st is also 2. 2 times 2 is 4. 2 to the 2nd is also 4. Back up here, 2 to the 2nd times 2 to the 3rd. 2 to the 2nd is 4. 2 to the 3rd is 8. 4 times 8 is 32. And what is 2 to the 5th? It's 32. So we can see that that does, in fact, check out. Let's come down here to our last example. Here we're going to use a fraction as our exponent, and our fraction here is going to be 1/2. Using our same properties here, 2 to the 1/2 times 2 to the 1/2, we have the same base in both, 2. That means we take our exponents and we add them together. What is 1/2 plus 1/2? Well, that is 1. So then, is 2 to the 1/2 times 2 to the 1/2 the same thing as 2 to the 1st? Yes, it is. What number times itself equals 2 to the 1st? Well, the number times itself that equals 2 to the 1st is going to be the square root of 2. The square root of 2 times the square root of 2 is going to equal 2 to the 1st, which is the same thing as 2. So we can see here that using exponents, and in particular the exponent 1/2, to represent the square root of a number is in fact a very valid method. So then over here on our second page, we can use this to also help us solve problems that have either multiple components to it or several variables, or one or more variables. Our first example here, in parentheses we have x times y. And within that parentheses, we're taking that whole expression to the 1/2. Well, remember from our properties from before, we can take this exponent to each of the parts. So xy to the 1/2 is the same thing as x to the 1/2 times y to the 1/2. Well, if it helps you or it's more beneficial for you to see the radical sign, we could rewrite xy to the 1/2 as radical x times y. Well, with that being the case, using our property from up here, radical xy is going to be the same thing as radical x times radical y. And that is oftentimes helpful in solving problems, is taking a particular number and breaking it apart into smaller fractions or smaller factors, and then taking the square root of each of those factors. So let's go ahead now and take a look at a couple of examples. You have the square root of 45. The question is, simplify that. Well, what we need to do is to break 45 down into factors. But what we want to do is to get at least one of those factors of 45, if possible, that's a square. Well, 9 times 5 is 45. 15 times 3 is 45. Are 15 and 3 squares? No, they're not. Are 9 or a 5, because 9 times 5 is 45. Are 9 or 5 a square? Well, 9 is. 9 is the square of 3. So let's go ahead and rewrite this as the square root of 9 times 5. All we've done now is we've just simply taken the 45 and broken it down into 9 times 5. At this point here, we have an expression similar to our xy. The square root of x times y, the square root of 9 times 5, is now going to be the square root of each of the two factors, square root of each of the two parts. So we can break this down even further. The square root of 9 times 5 is going to be the square root of 9 times the square root of 5. 9 is a square. What is the square root of 9? The square root of 9 is 3. The square root of 5 cannot be broken down or simplified any further, so we just leave that alone. So our answer is 3 times radical 5. What is the square root of 45 in simplified form? 3 radical 5. Let's take a look at one more example, this time including one that has a variable in it. 12x to the 4th. And then we're going to put that within a radical sign. So the question is, simplify this monomial, the square root of 12x to the 4th. Well, once again, our strategy is wherever possible is to break down a number into squares. Because a square root of a square is going to be either an integer itself or it's going to be a monomial variable that does not have any other parts to it other than that entire whole answer broken into that part. So for example, 12 times x to the 4th. Well, we could rewrite that if it helps us to see it here. 12 times x to the 4th. So the square root of 12x to the 4th is the same thing as the square root of 12 times the square root of x to the 4th. Well, x to the 4th is already a square, so we don't have to do anything else with it. However, let's deal with this 12. Our 12 is not a square. But does 12 have any factors that are squares? Well, 2 times 6 is 12. Is either 2 or 6 a square? No. 3 times 4 is also 12. Are either 3 or 4 a square? Yes, 4 is. So what I'm going to do is just rewrite this now in a different color. 12, the square root of 12x to the 4th is going to be the square root of 4 times 3. And then that's going to be multiplied by the square root of x to the 4th. I just copied down the x to the 4th from above, and I rewrote radical 12 as radical 4 times 3. Now let's break it apart even further and simplify it even further. What is the square root of 4? Square root of 4 is 2. And remember, we can break this apart. I probably should go ahead and write it here. The square root of 4 times 3 is the same thing as the square root of 4 times the square root of 3. Then we're going to be taking that and multiplying it by our square root of x to the 4th. Got a little ahead of myself there, so let's go ahead and just erase that too. So what I've done now is I've rewritten, starting again, radical 12x to the 4th. We broke that into radical 12 times radical x to the 4th. We took our radical 12 and rewrote it as radical 4 times 3. We leave our x to the 4th alone. It's already a square. Then we took our radical 4 times 3 and broke it into the part. Radical 4 times radical 3, then times radical x to the 4th. What is radical 4? Radical 4 is 2. In other words, the square root of 4 is 2. We're going to skip this because the square root of 3 can't be simplified. So the square root of 4 is 2. What's the square root of x to the 4th? Well, that's x squared. And remember, everything here is being multiplied. So it doesn't matter which order we perform this multiplication. So the square root of x to the fourth is x squared. That takes care of that one. And then we're multiplying it by radical 3. Radical 3 cannot be simplified any further. So then the square root of 12x to the fourth in simplified format is going to be 2x squared times radical 3. And then as a quick review, simple radical form, a square root of a monomial is in simple radical form when there are no factors left that are squares of monomials other than 1 and -1. And then lastly, when trying to simplify the square root of a monomial, if possible, break apart the monomial into the product of squares, because the square root of a square is just going to be that square root itself. That'll help you simplify your monomial squares. Okay then, that'll finish up session 81.